Have you ever stepped outside on one of those really crisp, clear afternoons and noticed both the sun and the moon in the sky at the exact same time?
Oh, yeah. It's pretty common sight, especially in the fall.
Right. And when you look up, it feels like you're experiencing both of those celestial bodies together, perfectly synchronized in your present moment, like they are both happening right now.
But there is a massive catch to that experience.
A huge catch. Because the light hitting your eyes from the sun is actually, what, 8 minutes old?
Yep, about 8 minutes.
Yeah.
And the light hitting your eyes from the moon, that is only about 1 second old.
So even though you're looking at them simultaneously in your version of now, your eyes are actually collecting completely different slices of the past.
And your brain is just seamlessly stitching them together into a single, cohesive present. It really is a beautiful illusion when you stop to think about it.
It is. Our brains construct that reality for us every single day without us even noticing. And that exact illusion, how we perceive time, how space is laid out, and how information actually arrives at our doorstep, is basically the entire foundation of our deep dive today.
It absolutely is. We are looking into a highly unorthodox, deeply fascinating, and admittedly complex blog post today. It's titled Draft, Mr. Einstein's Slacking 112.
Which is a wild title.
It is. And the author is bringing forward a completely alternative, purely geometric perspective on how we observe the universe.
And the title alone tells you we are getting into some provocative territory. I mean, when someone brings up Albert Einstein and the word slacking in the same breath, they are taking aim at some foundational concepts.
So they're aiming right at the bedrock of modern physics. The core of this source is the claim that classical physics, and special relativity in particular, completely mishandle the concept of information delay.
Right. The author is essentially arguing that heavily relied upon concepts like Lorentz contraction are not physical realities at all.
No, they call them mathematical bandages, trying to cover up basic geometric oversights.
That is the crux of the argument, yes. But before we wade too deep into those waters, we do need to set a very firm boundary for you, the listener.
Definitely.
The source material we're unpacking today is fiercely critical of established theoretical physicists. The author goes so far as to call modern physicists math-obsessed and claims they have fundamentally lost touch with physical reality.
So we need to make it unequivocally clear that we are not taking a side here.
Exactly. We are not endorsing these critiques of Einstein, nor are we trying to dismantle modern physics. Our mission for this deep dive is simply to impartially convey the author's unique thought process.
We just want to explore the underlying logic of these alternative geometric models. We want to see what kind of aha moments we can extract from looking at the universe from such a radically different angle.
Right. We are here for the mental workout and the paradigm shift. We're not trying to rewrite the textbooks today.
So to get this mental workout started, the author uses a really fantastic grounding metaphor. Let's put you right in the middle of center court at Wimbledon.
Okay, I love this one. So you look around and you see player 1 winding up for a serve, player 2 bouncing on their toes, the umpire sitting up in their high chair.
The thousands of people in the audience surrounding you. It's this rich, dynamic, three-dimensional scene.
Right. Now take all of that and erase it.
Just wipe it completely clean. Erase the crowd, the players, the net, the grass. Keep stripping the scene down until you are nothing but a single dimensionless point of observation.
You are just a camera eye floating in empty space, sitting at the absolute zero-point center of a three-dimensional grid, suspended in the electromagnetic field.
And to really grasp the author's model, we need to draw a boundary around that camera eye.
A bubble, basically.
Yes, picture yourself at the center of that empty space, but now you're surrounded by a perfectly transparent spherical shell. The author calls this the unit circle, or the sphere model. Let's say this bubble has a radius of exactly 1 meter.
Okay, so I'm in a 1-meter bubble.
You're waiting inside this bubble for light, which the author specifically defines as information to reach you. And the entire geometric argument hinges on how long that journey takes.
Let's actually visualize the math here because it's pretty central. Let's say a light beam is traveling down a straight track that runs parallel to you, sitting just outside your 1-meter bubble.
Right. So if a flash of light goes off on that track directly across from you exactly 1 meter away, the distance it travels to reach your eye is 1 meter.
Simple enough. And because the speed of light is constant, we can easily calculate that time delay.
But what if the light flashes from a spot 1 meter away from your bubble, but also 1 meter down the track to your right?
It doesn't have a straight path to me anymore.
Exactly. It has to cut across empty space. It has to travel on a diagonal.
And using basic Pythagorean geometry, that diagonal distance is no longer 1 meter. It's a triangle with sides of 1 and 1, so the hypotenuse is the square root of 2.
Perfect. Now, if the light flashes from 2 meters down the track, the diagonal distance to your eye becomes the square root of 5.
And if it flashes 3 meters down the track, the diagonal distance is the square root of 10.
Right. The constant speed of light hasn't changed at all, but the actual physical distance the information has to, which is an entirely logical geometric deduction. It's just undeniable math. But what is fascinating is how the author uses this basic truth about diagonal distances to claim that Albert Einstein had a massive blind spot.
And this is where we get to the Mr. Einstein slacking part of the title.
Yes. Though it's worth noting, the author actually acknowledges that early in his career, Einstein understood physical grounding perfectly well.
Oh, really? So the author doesn't think Einstein was always wrong from the start?
Not at all. The source specifically points to Einstein's early work on Brownian motion.
Right. For context, Brownian motion describes the random, jittery movement of particles like pollen suspended in a liquid, constantly being bumped by invisible water molecules.
Exactly. And when Einstein calculated this, he used a very physical reference frame. He imagined a shallow plate or dish holding the water. The math was entirely grounded in the physical 3D reality of that plate.
But the author alleges that when Einstein later moved on to the physics of electromagnetism and light, he inexplicably abandoned the plate.
He essentially threw away the physical reference frame altogether.
The author argues that without that physical grounding, Einstein started doing the math in a void, completely ignoring the objective geometric reality of the electromagnetic field itself.
Precisely. And to illustrate just how damaging this supposedly was, the author asks us to deconstruct one of the most famous thought experiments in the history of relativity.
The moving train.
The moving train.
This is a total classic. In physics class, you are usually asked to imagine an observer standing exactly in the middle of a moving train car, or maybe standing in the middle of a massive track watching a train go by, and you measure how light behaves from those different perspectives.
But the author has a huge problem with this setup. By placing the observer's mind inside this one-dimensional line, just thinking about the x-axis, the forward and backward motion along the track, it creates a state of what the text calls narrowed thinking.
Narrowed thinking, meaning they get tunnel vision.
Exactly. It forces the physicist to ignore the three-dimensional reality of the space around the train.
So how does the author propose we fix the train experiment?
By introducing a concept they call the train king.
The train king. I love that imagery.
That's great. Instead of standing on the floor of the train looking forward, imagine an observer stuck to the ceiling of the moving train car, looking straight down at the floor as the train speeds along the tracks. The train king is ruling from above.
Okay, I have that in my head.
Now, if a beam of light flashes from the floor of the train, pointing straight up at the train king, what path does it take?
Well, normally you would just say it goes straight up.
But the train is moving forward. So by the time the light leaves the floor and travels the vertical distance, the ceiling and the train king's eye has moved forward in space.
Oh, I see. For the light to actually reach the observer, it cannot go straight up. It has to travel on a diagonal path through the electromagnetic field to catch up to the moving target.
It has to chase the ceiling.
It has to chase the ceiling. That is such a simple visualization, but it completely changes the geometry of the scenario.
And this is the author's central critique of the last 100 years of physics. By stripping away the 3D field and treating the train track as an abstract 1D line, physicists have ignored these physical diagonal paths.
Which means they're getting the distances wrong.
Exactly. The source claims that modern physics has effectively enslaved light to the observer. They forced the mathematics to revolve around what the human being sees, rather than respecting the objective geometry of how light actually moves through the field.
Okay, but as much as the author is critiquing this human-centric math, they do highlight one physicist who supposedly got it right, or at least closer to right. The text heaps a ton of praise on Hermann Minkowski. What did he do differently?
Well, Minkowski was actually one of Einstein's teachers, which adds a nice layer of historical irony to the author's argument.
That is ironic.
Very. The author is deeply appreciative of Minkowski's concept of the past light cone. If you want to visualize this, picture an hourglass, but we're only going to focus on the bottom half of the cone that points upward.
Okay, I've got the bottom half of the hourglass.
The very tip of that cone, the sharp point at the top where the sand would fall through, that represents you. That is your camera eye right now in the present moment.
And the wide base of the cone stretching downward.
That wide circular base at the bottom represents the past. It encompasses all the delayed light, All the information traveling from different distances and different angles, that is just finally arriving at the tip of the cone at time zero.
Oh, wow. So Minkowski geometrically mapped out the fact that our present moment is nothing but a collection of delayed information from the past, all arriving simultaneously.
Yes, which loops perfectly back to the sun and the moon analogy we started with.
It really does. The author is basically saying that this unit circle, that 1 meter bubble we visualize around our camera eye, isn't a physical object floating in space.
No, it's actually our retina.
Right. Our brains are taking all of these delayed signals, light from 8 minutes ago, light from 1 second ago, light that had to travel the square root of 10 units diagonally, and instantly projecting them onto an invisible dome inside our minds.
It creates a seamless, perfectly cohesive image of now, even though now is entirely made up of different pasts.
If we take a step back and look at the philosophical implications of that dome, we reach the most intense critique in the entire source. The author fundamentally believes that modern physicists have forgotten that this dome is just a projection.
This is where the term math-obsessed really comes into play. The author accuses theoretical physicists of mistaking their mathematical spaces for actual reality.
They are confusing the model of the universe for the universe itself.
Exactly. The text draws a very stark, almost aggressive comparison here. The author likens these physicists to generals sitting safely in a headquarters, surrounded by abstract maps and theoretical strategies.
And these generals send soldiers out to fight and die, completely disconnected from the harsh, muddy physical reality on the actual battlefield.
That is the analogy.
I mean, that is a really heavy analogy to throw at a theoretical physicist. Is it really fair to call them math-obsessed just because they use highly complex, abstract models to solve problems?
Well, according to the author, the problem isn't the math itself. It is the blind faith in the math. The argument is that physics is drifting away from objective geometry and turning into a patchwork of arbitrary human logic. And to drive this home, the author references Pascal's wager.
Wait, the philosophical argument about gambling on the existence of God?
Yes, that exact one. Blaise Pascal argued that since you cannot prove God exists, you should wager that he does, because the potential upside is infinite and the downside is minimal.
Okay, so how does the author flip this concept to criticize physicists?
They are arguing that treating complex mathematical equations as absolute physical reality is a massive gamble, and it is a gamble that ignores the oldest rule of modeling. The map is not the territory. The spreadsheet is not the actual business. The equation on the chalkboard is not the universe.
When you put it like that, you can see why the author thinks the field has lost its way. I mean, if a general's map doesn't show a mountain that actually exists on the battlefield, the soldiers pay the price. In physics, the author seems to be saying that when the map is flawed, physicists just invent wild new math to force the universe to fit their flawed map.
Which brings us to the climax of the entire source document. All of this groundwork, the Wimbledon camera eye, the square root diagonals, the train king chasing the ceiling, the generals confusing the map for the territory, it all builds to a massive fundamental reinterpretation of Lorentz contraction.
Okay, this is the big one. The author is taking aim directly at Lorentz contraction. Just to review, that's the established idea that objects physically shorten as they approach the speed of light. But instead of an object physically compressing, what are they arguing is actually happening?
The author claims that space does not physically curve or contract. Time does not literally flow differently for different observers, depending on how fast they're moving. According to this alternative geometric model, Lorentz contraction is nothing more than a mathematical patch.
A patch?
Yes. It is what the author calls a complex space conversion.
A patch for what exactly? What were they trying to fix?
They were trying to fix the fact that they ignored the diagonal time delays in the first place. Think back to the train track. The author argues that because early physicists looked at the track as a straight one-dimensional line instead of a dynamic three-dimensional field, their math was slightly off.
Because they weren't accounting for the angles.
Right. When calculating how light reaches the observer's camera eye from the far ends of a moving train, they forgot to account for those square root diagonal delays we talked about.
Wait, let me make sure I'm grasping the scale of this claim. The author is saying that because physicists missed a basic geometric delay because they forgot to use the Pythagorean theorem to calculate the diagonal paths of light, they had to invent the idea that the train itself was shrinking just to make the math work out.
That is precisely the claim. Because the time arrivals of the light didn't match their one-dimensional math, they had to invent highly abstract, complex equations to force the information to arrive on time. The author calls this corrected, patched-up visual image the screen of
The
distance.
screen of distance.
Yes. Think of it as a purely optical effect caused by delayed information. It is very similar to how a straight stick looks bent or broken when you dip it into a glass of water.
Oh, that's a great comparison.
Right. It is an illusion of perception caused by how light travels. It is not a physical warping of the universe's fabric. The author believes Lorentz contraction is just an optical illusion created by mathematical errors, codified into a universal law by generals looking at the wrong map.
That is a staggering conclusion to reach. Let's just take a breath and synthesize the incredible journey this author just took us on.
It's quite a ride.
They didn't start with quantum mechanics or string theory. They started with a simple, undeniable, everyday fact. Light takes time to travel from point A to point B. And then, step by step, just by drawing straight lines and diagonals on a grid, they used that simple fact to completely deconstruct one of the most famous and widely accepted theories in modern physics.
It's a bold move.
To claim that our entire conception of relativity is essentially a typo caused by ignoring diagonal geometry is wildly ambitious.
It is incredibly ambitious. But whether you completely accept the author's geometric physics or you firmly side with Einstein and the established scientific consensus, there is an undeniable value in this deep dive for you, the listener. What the author has provided here is an absolute masterclass in critical thinking.
How so?
Because it forces us to practice the art of dismantling a widely accepted truth by returning to the most basic, fundamental realities. It is a powerful exercise in checking our own assumptions.
It really is.
It forces us to ask ourselves, in our own lives, in our own professions, have our maps drifted completely away from the territory? Are we, like the generals in the headquarters, applying complex patches to solve problems that are actually just basic errors in our foundational geometry? It is a reminder to always look for the hidden diagonal delays in our own logic.
I love that takeaway. It makes you want to audit every assumption you have ever made. And honestly, it really changes how you think about how we walk through the world tomorrow. In fact, I want to leave you with a final thought to mull over, something that takes the author's premise and pushes it just a little bit further into your everyday life.
Okay, where are we going with this?
Well, throughout this whole exploration, the author focused entirely on visual information delay. We talked about light traveling to the camera eye to prove that our perception of the present is an illusion stitched together from different slices of the past. But what if we applied this exact same logic to the rest of our senses?
Oh, that is a very interesting extension of the premise, because the delay of information isn't limited to just the electromagnetic field.
Think about it. The electrical signals from your fingertips take a measurable amount of physical time to travel up your nervous system, through your arm, and into your brain.
And the signals from your toes take even longer because they have a further distance to travel?
They have a longer track to run down before they reach the camera eye of your brain.
That's entirely true.
Exactly. So does that mean the physical object you think you're touching right now is also a delayed projection? If visual reality requires a massive, complex math patch just to understand how a beam of light hits an eye, what kind of invisible patches is your brain constantly applying in the background just to let you hold a hot cup of coffee without dropping it?
That's wild to think about.
If the present moment is an illusion for your eyes, it has to be an illusion for your hands, too. Good luck looking at the world, or even touching it the same way after that one.